So the 25 degrees Celsius that they offer as a piece of information at the beginning of the question is actually not relevant to the solving of the equation. Sometimes they do that. They'll give you extra information that you don't need. All you need is the mass and the volume if they're asking you for the density, or any one of the two parameters is needed to solve for the third one that they're asking for. In this case, what they're asking for is the density. So 76.31 grams divided by 1.5 centimeters per side. If you look at the information, it says that the cube is 1.5 centimeters per side. Recall that when you draw a cube, there are 3 dimensions to take into account. If they tell you the cube is 1.5 centimeters in height, that means it's also going to be 1.5 and 1.5 for the other 2 dimensions, because a cube is symmetrical and all the sides are the same length. Otherwise, by definition, it's not going to be a cube. All the sides have to be the same length. So if they tell you the length of one side on a cube, you know the length of all the sides on the cube. And therefore, when you take the volume of the cube, you're going to raise the length of one side to the power of 3, because in a cube, length times width times height is equal to volume. But because length equals width equals height in a cube, therefore you can say length cubed is equal to height. Is equal to volume. Okay, so that's the reasoning behind why I just took that one number and raised it to the power of 3. Can you follow what I did? Yeah, you see how it's all logical? So volume of a cube, length times width times height. But length and width and height are the same. So you can just take one of them and raise it to the power of 3, and you won't say anything wrong. And that's what I did there. Okay, so I did 76.31 divided by 1.5, and you get a density of 22.610, 3704 grams per centimeter cubed. But we can't report that answer. That's too many significant figures. We're only allowed up to 4. See, this one's got 4, that one's got 4. So our answer can only have 4 numbers in it. So I cut it off over here, because that's where you get 4 numbers. And I rounded down to 1, because the next number is a 0. So even in this, there's a lot of little details to get it right. Question B. The density of titanium metal is 4.51 grams per centimeter cubed at 25 degrees Celsius. What mass of titanium displaces 65.8 milliliters of water at 25 degrees Celsius? Again, they keep on mentioning temperature. The temperature doesn't enter into it in this calculation. But why might it be important to mention temperature when you're dealing with something? What happens to things when they get warm or cold? For example, what happens to metal when you heat it up? Some of the things that happen to it. Have you ever crossed the bridge and noticed there's a bump every few seconds when you're driving? Why do you think that is? Have you ever noticed how a bridge has all these little things that look like this? They're often intertwined. And what happens is in the summertime, the bridge actually gets longer. So they build the bridge just a little bit short, because in the summertime when the pavement heats up, the bridge gets longer and the pieces push together even more. If they built the bridge exactly the right length, when it expands, it would have nowhere to go, and it would actually push up. You'd get a big bump on the bridge, and it would actually ruin the bridge over time. So they naturally build in expansion joints in the bridge, so that when it gets warmer, the bridge can expand a little bit and it can move. And obviously they have to keep the expansion joints clean, because if you get dirt packed in there, then the bridge is going to try to push on the dirt, and it won't be able to expand. The same thing happens if you ever notice, when they build concrete sidewalks, every so often they cut the cement. Why do they do that? Why would you cut your brand new cement? It's because the cement, when it warms up, it expands. So they give it room to expand, that little bit that it has to expand. Even train tracks will expand. And what happens with train tracks is they build a very slight up and down, and that allows for when the train tracks to warm up, they actually expand very slightly. You won't see it if you're looking at even with your eye, because it's over a long distance, but it's just enough mobility so that the tracks, they slide inside those little pins that they put them on top of the wooden ties, but it's enough movement so that on a warm summer day, when the train tracks get longer, they have room to expand. In the old days, they used to have an actual gap. So when the trains would go on the track, you'd hear ta-ting, ta-ta, ta-tang, ta-tang, you know, every time the wheel hit that joint, it would make a clacking sound. But they figured out a better way of doing it over the years, where they just put a very gentle curve in the track that you can't even notice by looking at it, but it's enough to give it room to expand. So metals expand when you heat them, and that's why they always mention the temperature when they do scientific measurements, because it's important to know, in some circumstances, it's important to know that the thing has expanded. Because if it expands too much, in some situations, you might not get, some machine would stop working because the parts would start jamming. So all that has to be taken into account with engineering. Okay, so once you get the answer, in this case as well, you get 6 numbers in it, so you reduce it to 3 because there's only 3 significant figures in the numbers that you use to calculate it. Did anyone actually get the same answers that I got? Okay, it's good to try the homework before I do it on the board. Don't wait for me to do it on the board to copy it. That's not going to teach you very much. You're not going to be able to, that's not going to create anywhere near as much learning as if you try to do it at home. Even if you get stuck, at least you tried, at least you copied the question down, at least you set up the variables in some way, you got some part of it done. And the next day you'll get a bit further along until eventually you can do the whole thing. C. 128C. The density of benzene at 15 degrees Celsius is 0.8787 grams per milliliter. Calculate the mass of 0.15 liters of benzene at this temperature. So I use density equals mass over volume. I rearrange the equation. By the way, when I rearrange the equation, there's a trick you can use in math. It's called transposition. If something is in the denominator and you bring it to the other side, when you bring it to the other side, it ends up in the numerator. It's called transposing the variable. So that's how I isolated m. It's a kind of a shortcut way of doing the same thing as when you say, let's multiply both sides by v and then cancel the v's, you get the same result. But if you can recognize that a division becomes a multiplication, you can do it even faster. So 0.8787 grams per milliliter is the density of the benzene. And you have 15 milliliters, which is 0.15 of a liter. Multiply that by 1,000 milliliters per liter. Cancel all the units that you can. The only thing you're left with is grams. So you get 131.805 grams of benzene, and then you reduce it to the 4 significant figures that you're allowed to use, because that's what all the numbers are up to. And that's the answer, 131.8. 129A. To identify a liquid substance, the student determined its density. Using a graduated cylinder, she measured out a 45 milliliter sample of the substance. She then measured the mass of the sample, finding that it weighed 38.5 grams. People who work with winemaking use a density measurements to find out how much alcohol is in wine. As the yeast makes alcohol, the density of the solution drops because you're using up, the yeast uses up the sugar and turns it into ethanol. So the density, you can buy a little floating glass thing that you put in the wine, and depending on how high it floats in the wine, it tells you how much alcohol you have in the wine. So it's basically a densitometer. They used to use the same thing for car batteries. Back in the old days, car batteries used to be openable. So you could find out what the density of the liquid in the battery was, and that would tell you the state of the battery. Now the batteries are sealed because probably a lot of people burn themselves with the acid. Battery acid is pretty nasty. It burns through everything because it's sulfuric acid. So I remember once I assembled a battery that I had bought for my motorcycle on the kitchen table, and I got 1 drop of acid, sort of went down the side of the battery and made a big hole in the tablecloth, made a black stain on the table. It took a long time to get out. So yeah, you got to be careful with sulfuric acid. It's pretty powerful stuff. So anyway, 129A, I set up density equals mass over volume. It's very straightforward. Here's the mass, here's the volume. You get 0.85 grams per milliliter, and they tell you oh, wait a minute. Yeah, they gave you 2 densities. One was isopropyl alcohol at 0.785, and the other one was toluene with a density of 0.866. Well, 0.85 is closer to 0.866 than it is to 0.785, so this is probably toluene. It's not 100% sure, but this is pretty close. Remember, in every measurement you make, you're going to get little mistakes, little errors, and that's why you don't always get perfect results when you do something. 129b, an experiment requires 45 grams of ethylene glycol, a liquid whose density is 1.114 grams per milliliter. Rather than weigh the sample on a balance, a chemist chooses to dispense the liquid using a graduated cylinder. A graduated cylinder is basically a tall, skinny container with a bottom, and it's got little marks on it, and you can measure how much liquid you put in it, and from the measurement you can tell how much liquid you have. So rather than weigh the sample on a balance, the chemist chooses to dispense the liquid using a graduated cylinder. What volume of the liquid should he use? So in this case, we're trying to solve for volume. We have 45 grams of liquid, and the density of the liquid is 1.114. Grams cancel, and you get milliliters. Again, you get lots of decimal places in your calculator, so when you report it, you only report it to three significant figures. (29C). A cubic piece of metal measures 5 centimeters on each edge. If the metal is nickel, whose density is 8.9 grams per centimeter cubed, what is the mass of the cube? Similar setup as before, except now we're trying to find the mass. So I isolated the V. So I isolated the M by transposing the V. Density times volume equals mass. This 5 centimeters is raised to the power of 3. Why? Because it's a cube and it has 3 dimensions. Same reasoning as over here. Okay, it's 5 by 5 by 5, so it's 5 centimeters, all cubed. By the way, here's a trick question. Just a little aside. What is the difference this comes up often enough that I want to address it right away. What is the difference between 5 centimeters cubed and 5 centimeters all cubed and 5 cubed centimeters? Is there any difference? No? Trick question. If somebody can explain it to me, I'll give you a bonus.
They're the same?
They're not the same. They're completely different. Who can explain to me why they're completely different? Look, you got 5 centimeters cubed. That's 5 centimeters that are cubed. So whatever the thing is, it's a tiny cube with a total volume of 5 centimeters cubed. It's going to be a small cube. 5 centimeters all cubed means you're cubing the 5 and you're cubing the centimeters. So 5 cubed is actually 125. So it's actually 125 centimeters cubed. It's a big cube. This is a small cube. This is big. And this is 125 centimeters. So it's a big line. That's the difference. All right? So where you put your power makes a big difference. See, if you put a bracket around it and raise it to the power of 3, you're cubing everything in there. If on the other hand, you're just cubing the number, you just get a bigger number. And if you just cube the unit, you get a volume measurement, but because you haven't cubed the number stays small, like what it was originally. I should turn the camera so you can see what I'm talking about. Okay, so just keep a note of that, because if you're sloppy in writing your powers, you can generate mistakes in the calculation just by not paying attention to that little detail. Okay, go back. Now we're doing 129C. 129C. So I've rearranged the V so the density times volume using the mass. I raised the 5 to the power of 3. I multiply by the volume. No, the density. This is the volume, that's the density. Total mass is 1,112.5. I'm only allowed 3 sig figs because there's only 3 significant figures in each one of these. So my answer can only have 3 numbers. So you get 1.11 times 10 to the power of 3 grams. 130A. After the label fell off a bottle containing a clear liquid believed to be benzene, a chemist measured the density of the liquid to verify its identity. A 25 milliliter portion of the liquid had a mass of 21.95 grams. A chemistry handbook lists the density of benzene at 15 degrees Celsius as 0.8787 grams per milliliter. Is the calculated density in agreement with the tabulated value? So again, we set up density equals mass over volume. Here's the mass, here's the volume, and you get 0.878. As compared to 0.8787, I say close enough. I would say yes, that was a sample of benzene. 130B. An experiment requires 15 grams of cyclohexane, whose density at 25 degrees Celsius is 0.7781 grams per milliliter. What volume of hexane should be used? So now we're looking for volume. Density equals mass over volume, but if you bring up the volume and then bring down the density, you get this. Volume is equal to mass over density. 15 grams divided by 0.7781 gives you 19.27 milliliters. We're only allowed 3 sig figs, so we've got to cut it off at 3. Because this is a 7, we round up and it becomes 19.3 milliliters as your final answer, which would be correct. D of 130. A spherical, no, sorry, that would be C. A spherical ball of lead has a diameter of 5 centimeters. What is the mass of the sphere if lead has a density of 11.34 grams per centimeter cubed? Mind you, the volume of a sphere is 4.4 over 3 pi r cubed, where r is the radius. So let's start off by putting down what we know. We know that the diameter of the sphere is 5 centimeters. That means its radius is half of that, or 2.5. We know that the volume of a sphere is given by the formula 4 over 3 pi r cubed. So we take this number and plug it into the formula, and that gives us the volume of our little lead ball, which we're going to plug in. Once we find it, it's going to be here. It's this number here. So once we solve that formula, that's what we get. Then we're using the formula density equals mass over volume, but this time we're solving for mass. So we transpose the V. There's the density of lead. Here's the volume of the ball. And this is what the lead ball would weigh. And then we're only allowed 2 significant figures because they said 2.5, they said 5.0. That's only 2 sig figures. So that limits the accuracy we can report it with. That's why I reported the answer with only 2 numbers. The last question, if you could do that by yourself, I'd be very impressed. But let's read the question and I'll do it with you. It says gold can be hammered into extremely thin sheets called gold leaf. Because gold, one of the properties of gold is that it has extreme ductility. You can really flatten gold to a very, very thin sheet. In fact, some people even put gold sheet on their cakes, and they eat the gold. And the sheet is so thin that it doesn't really. And plus, gold is inert, so it passes right through your body. But although there are medicines where they have gold as one of the atoms, and they've been used with some success in the treatment of things like rheumatoid arthritis. There's one drug I know of called Oronophin. Pretty cool name, right? Oronophin, because it's named after the fact that it's got gold in it. And they give it to people who have inflammatory diseases. But nowadays, I think the gold standard for inflammation is a drug called methotrexate, which is used as an anti-cancer drug. But if you take it in low doses, it can help reduce a lot of forms of inflammation. That and prednisone, which is a corticosteroid. Anyway. Oh, you know what's another one that's interesting? Hydroxychloroquine. Hydroxychloroquine is used in many diseases where there's inflammation and the person has like autoimmune problems all over their body, there are many doctors that prescribe hydroxychloroquine, which is why I found it extremely strange when the medical community banned the use of hydroxychloroquine in the treatment of COVID-19. Because there were doctors saying that they were having good success in its use when it was combined with zinc. All of a sudden it became illegal. Oh no, it causes heart problems. And I looked into it, and the study where the people had heart problems were getting 600 milligrams of the drug per day, which is a very high dose. It was right at the limit of what is considered safe. That's why they were getting heart problems. The doctor who was prescribing the use of hydroxychloroquine was saying only use 200 milligrams twice a day, so a total dose of 400. That's already high. But those people never got any heart problems. So when I started seeing that the reporting was saying the drug is dangerous, I became skeptical about what the medical community was telling us. And I'm still very skeptical. I see evidence of corruption. There's evidence of corruption. That's one of those things where, you know, if somebody lies to you once, you don't trust them right away after that. If you catch somebody telling you a lie, the next time they tell you something where you have to trust them, you're going to look at them askance. You're going to raise an eyebrow when they tell you stuff where you're expected to trust them, because now they've broken their trust by lying to you on something important. So, you know, be careful when you tell lies to get out of trouble or whatever. You could lose credibility very quickly. People might not even tell you, but you will lose credibility, guaranteed. You know, have you ever heard the fable of the boy cried wolf? And the boy cried wolf, 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 and everybody came running. And they said, where's the wolf, where's the wolf? And he says, oh, there's no wolf, I was just playing a joke on you. And then he did it a couple more times, and then finally the fourth time there was a wolf. He was like, wolf, wolf, wolf. Nobody came, and all the sheep got killed or eaten because the people weren't listening to him and they didn't believe him. They always tell stories like that to little kids to help them understand that it's important to tell the truth. But, you know, they should maybe retell the stories to some politicians and to some medical professionals who are making money from the propagation of not 100% truth. You know, especially when they're trying to sell you something that's very expensive. And they know that if they let you take some other form of treatment, they're not going to be able to sell you that expensive thing. That's where you have to look out for the possibility that people are not always going to be 100% honest with you. When you've got something valuable, there are some people who are going to lie to you to take it from you. And when you want to make something when you want to take some money or make something of high value, when you want to acquire something of high value, there are always going to be people who are prepared to set aside their morals in order to achieve it. You always have to operate with that possibility at the back of your mind, or else you go through life with your eyes closed and people will be able to lie to you continuously and get away with what they're doing. So anyway, let's get back to the lesson. The gold can be hammered into extremely thin sheets called gold leaf. If a 200 milligram piece of gold, density of 19.22 grams per centimeter cubed, is hammered into a sheet measuring 2.4 by 1 foot, what is the average thickness of the sheet in meters? How might the thickness be expressed without exponential notation using an appropriate metric prefix? So they told you the sheet is 2.4 feet long, 1 foot wide, but you don't know how thick it is. What shape is that? Length, width, and some height. What shape is that? You guys remember geometry? What is the shape called when you have length times width times height and they're all the same? No, not a square. No.
A right angle triangle?
Okay, it's got a square shape. If they're all the same length, okay, you got the answer to the first question. But I'm asking another question now. If you got something where you have length, width, and height, and they're all the same.
Andrew, please come to the main office, please. Andrew, thank you.
What are they called? What's it called? I said it over here.
A cube?
A cube, right? A cube has all the same length size. Now, what if you have a shape that would be a cube, except the length and the width are different, and the height is very, very short? It's a rectangular prism. Remember then, right? Good. So what we have here is a very thin rectangular prism. It's 2.4 feet long, 1 foot wide, and I don't know how tall. That's what we're going to try to find out. But it is a rectangular prism, just a very skinny one. Okay, so the first thing we're going to do in this problem is find out how much volume our little rectangular prism has. So density equals mass over volume. We're going to solve for volume. We get 0.2 grams divided by the density of gold. So we find out that the rectangular prism made of gold in this problem has this volume. So this is the volume of rectangular prism made of gold. You need to have imagination to solve science problems. You have to be able to picture the thing in your mind, rotate it in your mind, and see the different dimensions. And that, if you can do that, you'll be able to solve these kind of problems more easily. They told us it's 2.4 feet long and 1 foot wide. So I'm going to convert the measurements what did I do here? Okay, 2 by 4 by 2.54, and then basically I'm converting the area. I'm finding the area of the thing. Okay, so the area is, I shouldn't have put it squared here. That's why it's confusing. So I'm 2.4 by 12. Oh, that's why. Okay, yeah, I do have to leave it in there. It's because I multiplied it by 1 foot. Okay, so this part should be like that. That's it. So it's 1 foot by 2.4 feet by 12 inches squared by 2.54. So just correct that in your papers because I forgot to write the 1 foot part. Okay, so that gives you the volume of your rectangular prism. And if you remember, if you know the volume of something and you divide it by the, suppose I knew the volume of this thing was 8. Okay, if this whole thing was 8 centimeters cubed. And I knew that this part had an area of 4. What would the height have to be? If the area of the top of this cube was 4 centimeters squared, and I knew that the whole volume was 8, what would this height have to be then? Would it have to be, 2? Because 2 times 4 gives you 8. All right, so that's what we're doing here. We're finding the volume of the whole rectangular prism, and we know the area of the top part. So if you take the volume and you divide it by the area, it's going to give you the height. If I know the volume and then divide it by the area, it's going to give me the height. 8 divided by 4 is going to give me 2. Except here the numbers are not even numbers, right? So here's the volume of the thing, here's the area of the top of it, and we're trying to find the height. I found the height in centimeters, and I turned it into meters, and then I turned it back into nanometers, so the answer you get is 46 nanometers thick. So you get a very thin layer of gold, 46 billionths of a meter thick, and that's the homework for today, and I'm going to stop recording.